Hello everyone, I am Bartu Bishkin.
I am Jerzy Gutjarkowski.
I am Irfan Abedi.
I'm Martin Mauser.
I am Name Uruz.
And we're very excited to share with you our project, the Quantum Singular Value Transformation with Qiskit, or QSVT for short. QSVT is a relatively new framework for building quantum algorithms. It allows us to implement arbitrary functions, which are not necessarily unitaries. It also allows us to recast many known quantum algorithms in terms of the same simple circuit structure, serving as a unification scheme for these quantum algorithms. So, what is QSVT and how does it work?
QSVT is based on two main ideas. These are block encoding and quantum signal processing, or QSP. Block encoding is the procedure where you encode a matrix of interest, which is not necessarily unitary, inside the upper left corner of a bigger matrix, which is a unitary and therefore a valid quantum gate.
Quantum signal processing is a guideline for creating polynomial approximations to smooth functions by applying parameterized rotations iteratively. The parameters for rotations are the so-called QSP phase factors, and each function has its own unique factors.
QSVT then wraps up these two ideas neatly and tells us that one can perform this polynomial transformation upon this encoded block inside the unitary.
To make things a bit more concrete, for example, you could encode a Hamiltonian, a non-unitary Hermitian matrix, inside a bigger matrix, which is indeed a unitary and a valid quantum gate, and then perform exponentiation directly on this block by choosing the appropriate quantum signal processing phase factors for the exponential function. This is game-changing.
There are many QSVT implementable quantum algorithms, such as search, simulation, and factoring. In our project, we have chosen the simplest of these, the Grover's quantum search. We aim to bridge the gap between academia and the broader Qiskit community that exists around this topic of QSVT. And we think that quantum search is a very intuitive place to start. To perform a search, the matrix that we want to encode is actually 1 by 1. In other words, it's a scalar, which is the inner product of the initial and the target states. After encoding this inner product inside a unitary, we can then perform a transformation that would take this inner product from whatever value it has to the value of 1, making a complete overlap between the initial and the target states, resulting in the discovery of the marked state.
This working principle of QSVT search is fundamentally different from the original Grover's search in the sense that it is not flipping the sign of the marked element to perform amplification, but it directly transforms the inner product by using some kind of polynomial.
We are very happy to be a part of this amazing community, and we hope that our work here serves as a simple introduction to the groundbreaking ideas of quantum singular value transformation. Thank you.